good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have already finished the chapter Newton's laws of motion. Today, we will be discussing two specific problems on based on Newton's second law. Okay, so what are those problems? Just let us see. These problems, I have just taken these problems from the conscience physics book. Okay. So let us see how can we solve this problem. So it is very important that when you solve any physics problem, numerical problem, it is very important that you first of all write down the given informations, okay, and see what you have to calculate, okay. Accordingly, think of which formula you can apply, and it will be easier for you to solve the problem. Okay. So let us see what is the problem given. I am just noting down the problem just for once. It will be easier for all you to follow. So it is saying that okay. So there was some power issue. Now let us continue. See the example, the numerical that we are talking of. It is saying that a car is moving with a uniform velocity with an uniform velocity of 30 meter per second. Fine. Then it is said that it is stopped in 2 seconds. In 2 seconds by applying a force of 1500 Newton through brakes, okay, through brakes. Fine. So what we have to calculate? It is said that calculate number 1 or part A is change in momentum of car. Change in momentum of car. So part 2, it is said retardation produced in car. Retardation produced in car, and the subpart 3 says that is asking that what is the mass of the car. The mass of the car. So these are the given that has been said in the problem. We need to analyze the given information from here and solve out the problem. So let us see. So first of all, what are the things given that are in the things that are given? Let us just note it down on the right side of the board. Okay. So the given information says something like this, that the car is initially moving with a uniform velocity. So this is the car is moving with an uniform velocity. This velocity is basically the initial velocity. So you can say that initial velocity is denoted by the letter u. So initial velocity u is 30 meter per second. Fine. Then what is given? It is stopped in 2 seconds. So when you are saying that it is stopped in 2 seconds, definitely what does it mean? That the car comes to rest. So the final velocity must be 0. So final velocity, it is denoted by the letter v. Final velocity denoted by the letter v is 0 meter per second. Fine. Time taken for this is 2 seconds. So time taken denoted by the letter t is 2 seconds. Then what is force applied? So force, in short we take it as capital F, is equals to 1500 Newton. Fine. So these are the things that have been given, provided in the numerical problem. Okay. So what we need to find out? We need to find out the change in momentum of the car. So what is the change in momentum. Now see, you know momentum means the mass multiplied by the velocity. Okay, so I am just erasing the problem so that I can do the solution in this space. Okay, so we have already noted down the given information. So the first thing that we need to do is to find out the change in momentum. So part A. So basically momentum means mass multiplied by velocity. So initially the car was moving, it was having some velocity. So can I write like this, that initial momentum is initial momentum, but for that you need to have the knowledge about the mass. The mass is not given. The mass itself has to be calculated in third part. So how else can we calculate the change in momentum? See, you have already learned in Newton's second law that the force applied on a body is directly proportional to the rate of change of momentum, isn't it? So can we write it like this, that the rate of change of momentum delta P by delta T is equal to the force applied. Now what is delta P? It is a change in momentum. What is delta T? It is the time duration for which this change happens, and it is a force. So from this can we write delta P is what you need to find out the change in momentum. Delta T is 2 seconds. It is equals to 1500 Newton of force. So from this can we write that delta P is equals to 1500 into 2. This gives 3000. Okay, 3000. So therefore change in momentum is equal to 3000 kg meter second inverse. Okay, so this is the calculation. So I think it is clear. So delta P by delta T is equal to, we know this from the Newton's second law. Using that formula we have found out the given solution. Okay, the next part says that what is the retardation produced in the car? Retardation produced in the car. So what is the retardation? Now see, for this you have to calculate. Your given initial speed is 30 meter per second, final speed is 0 meter per second, and time taken is 2. So I think all of you have remembered the first equation of motion, V is equal to U plus AT. Okay, so considering that, so let us do the second part. Second part of the problem says that V is equals to U plus AT. This is the equation, first equation of motion that we have already done. So you need to calculate the A, because V is given. V, it is how much? V is 0. U is how much? 30. Plus, let us consider that the acceleration is A. So A into time t means 2. So from this can we write that 2A is equal to minus 30, or A is equal to minus 30 by 2, that is equal to minus 15. So the A here, A actually denotes the acceleration in the equation. So when its value comes out to be negative, so can we say that this A is actually the retardation, isn't it? So we can write therefore retardation is nothing but equals to 15 meter per second square. Okay, so this is the retardation. And what is the third part says? The third part says what is the mass of the car. So what is the mass of the car? For this we can now very easily apply the formula that force is equals to mass into acceleration, isn't it? So force is equals to mass into acceleration. We have also, this is another form of Newton's second law, so you can easily apply that form. So third part says that force is equals to mass into acceleration. Here it is retardation in this case. Okay, so the force applied is 1500. We need to calculate the mass, let it be m, into A. A means the value of A is here 15. So the mass of the body is 1500 by 15, that turns out to be 100. Okay, is it okay? So you can write therefore mass is equal to 100 kg. Why? Because why the unit kg is coming? Because you have taken or done all total calculations in SI units. So the mass turns out to be 100 kg. Okay, is it clear? Fine. So this was what the problem. So this is how you can solve the problem. See, it's not tough, it's rather easy. You just need to note down what are the given informations. That is very, very important. That is the first thing that we need to do. Then you need to think of what you have to calculate. Think about the formulas available to you, and you can easily get the solution. Okay. So I think we can do another problem. So let us just quickly move on to the second problem. What does the second problem says? Okay. So again I am writing the question first, and as I have said that we are discussing these questions from the conscience physics books. Okay. So these are present in your exercise. You can see it if you have the book with you. You can see. Others who don't have the book with them, for them I am just writing the question so that it is easier for them to understand. Okay. So next question, question number 2. What does it says? A bullet, okay, of mass 50 gram. Bullet should not be. It is a less mass. 50 gram. Moving with an initial velocity of 100 meter per second. Definitely it is bullet, so it should be moving with a high speed, 100 meter per second. Fine. It strikes a wooden block, okay, and comes to rest after penetrating a distance of 2 cm. Penetrating a distance of 2 cm. Fine. Okay. So what you have to calculate? First subpart, we need to calculate the initial momentum of bullet. Okay. Second thing that you need to calculate is the final momentum of bullet. So final momentum of bullet. Third part that you need to calculate is the retardation caused by the wooden block. So I am just writing retardation, okay. And the fourth part says the resistive force exerted by the wooden block. So I am not writing the full details, I am just writing the resistive force. Okay. So these are the given informations. Fine. So this is the problem, and this is what you have to find out. So let us see. So what are the given information? Just let me note it down on the side of the board. So given information. What are the given information? First of all, the mass of the bullet is 50 gram. So mass m denoted by m, it's 50 gram. So can we convert it into SI? Yes, definitely yes. So 50 by 1000. It turns out to be like this. 50 by 1000. So 20. So it's 1 by 20 kg. Okay. Second thing, initial velocity. So initial velocity. What is the initial velocity denoted by? It is denoted by the letter U. It is 100 meter per second. Fine. Comes to rest. See, it doesn't say it comes to rest. So final velocity, how much it would be? Final velocity would be denoted by the letter V. It will be definitely 0 meter per second as it is coming to rest. Okay, and it has penetrated a distance of 2 cm. So distance denoted by the letter S. It has penetrated a distance of 2 cm. Converting it into SI, it will be 2 by 100. That turns out to be 0.02 meter. Okay, 0.02 meter. Fine. These are the given things. Now let us see what we need to calculate. We need to calculate the initial momentum. So quickly moving on to the solution. Initial momentum. Fine. So initial momentum, it will be given by the formula mass into initial velocity. So initial momentum is given by the formula. So first part of the solution, initial momentum denoted by the letter P subscript I. Initial momentum is equals to mass into initial velocity, m into u. So that turns out to be 1 by 20 into 100. This turns out to be 5 kg meter second inverse. Okay. Second part, it says the final momentum. So final momentum represented by the Fp subscript F. Okay, it should be m into v. So v is 0, so the momentum, final momentum turns out to be 0. Okay, so two parts are very easily solved. Okay, now what does the third part has been asked? It has been asked what is the retardation of the block. Retardation of the block. So how can you get it? Retardation of the block. Third part. So retardation can be obtained by the formula v square equals to u square plus 2as. So v square is equals to u square plus 2as. V square is 0. So 0 square, u square means 100 square. So this is 100 square plus 2 into retardation we do not know, let us consider it to be acceleration a multiplied by 0.02. So this turns out to be 2a into 0.02 equals to minus 100 into 100 square. Okay, then a will be equals to minus 100 into 100 by 2 into 0.02. So the calculations have been okay. So I think you can do the rest of the calculation. You will get the answer. Okay. So fine. So we have already obtained the retardation. Fine. Now what else we need to do? Now the last part is the force, resistive force. So for calculating the resistive force, what should we do? We should multiply the retardation with the mass. So resistive force is equals to mass into retardation. So you will get the value. Okay. So I think the solution is clear. So with that we come to the end of the class. Please continue with the classes. If you have any query, mention in the comment box. We will be happy to solve your problem. Till the next class. Thank you. Goodbye.